Hello, welcome once again to my eMath learning platform for applied mathematics this time around. In the previous lessons, we had pure math, but today we are going to now go through applied mathematics, and that is basically going to be continuous random variables. Now, without wasting time, we need to first know that if we have x and it is a continuous random variable with a PDF f of x valid over the range a less or equal to x less or equal to b, then the first fact or the first property in this case is that when you integrate this function here, f of x, which is our probability density function for all values of x, it should be able to get 1. Now this is best explained from this graph. As you can see, we have assumed that this is our curve y equals f of x, and it is within the interval a to b, and also as you look at it, this area which is shaded is enclosed by both lines x equals to a, x equals to b, and the x-axis. When you get the area under that curve, it should be in position to give you 1, and 1 in this case is the total probability. The next is that for a less or equal to x1, less or equal to x2, less or equal to b, the probability of x1 less or equal to x, less or equal to x2 is as good as the integral from x1 to x2 of f of x, but with respect to x. Now you need to understand this very well. We're looking at any two values, for example x1 and x2, which are within this interval here. That is why we are saying a less or equal to x1, and then x2 is also less or equal to b. So they are within that interval or within that range. It means the probability from x1 to x2 will be as good as integrating from x1 to x2. What are we integrating? That function f of x, but with respect to x. Now let us move direct to a few examples and look at how to apply this. So we have been given a probability density function representing a continuous random variable in this case. And they've given us f of x as kx squared from 0 to 4, then 0 otherwise. They're telling us to find the value of k, Roman 2, the probability from 1 to 3. So what do? We are going to begin right from the first property, especially for getting the constant. We shall begin from the fact that integral for all values of x, f of x, with respect to x should be 1. Now, this is a very good property that is going to help us, especially when we are looking for the values of the constants. Now, if this is true, it means I'm going to simply integrate this function here that I have from 0 to 4, and the sum or the integral should be in position to give me 1. So 0 to 4 of k x squared with respect to x should give me 1. Now we also need to have the knowledge of at least basic integration for us to be able to integrate this function. First of all, we need to know that k is a constant, and so it can come out of the integral sign. Then we remain with integral of x squared, but from 0 to 4, but with respect to x. All this is equals to 1. Now it means we shall have k, when we integrate x squared, we increase the power by 1, divide by the new power. So it means I'll have x cubed out of 3. I am applying square brackets before I substitute the limits, because I'm integrating from 0 to 4. Then from this level, we are now going to basically substitute the limits, and that will give us k. I'm now going to use curly brackets. It is now going to be 4 cubed out of 3 minus 0 cubed out of 3 minus 0 cubed out of 3. 0 cubed out of 3, and we expect all this to be giving us 1. So now, if you simplify this, of course, 4 cubed is going to be 64. So it means I'll have 64 out of 3, but 0 cubed is 0, divided by 3 you get 0. So it means I will have 64 out of 3k is equals to 1. And this will automatically imply that the value of k, this will imply that the value of k is going to be 3 out of 64. So the value of k in that case will be 3 out of 64. Now Roman 2 says we find the probability from 1 to 3. That is why they are saying 1 less or equal to x less or equal to 3. So as you can see, both 1 and 3 all lie in this range here. They all lie within the range. So it means we shall say a probability of 1 less or equal to x less or equal to 3 is going to be the same as the integral from 1 to 3. I integrate from 1 to 3, and I'm going to be integrating the same function. But remember, we already got the value of k as 3 out of 64. So I will say 3 out of 64 x squared with respect to x. Now, 3 out of 64 being a constant, you're also allowed to factorize it out or to have it out of the integral sign. So it will be 3 out of 64 integral from 1 to 3 of x squared with respect to x. Now that will give us 3 out of 64. If you integrate x squared, you will get x cubed out of 3. So we shall get x cubed out of 3, but our limits are from 1 to 3. Next step is going to be the substitution of limits. And so that will be 3 out of 64 into 3 cubed out of 3 minus, you now put a 1 there, that will be 1 cubed out of 3. Now when you have that, we can now be able to simplify this with our calculators. And when you do so, you will get 13 out of 32, which is very much accurate. And in case you can't avoid a fraction, I mean, if you can't avoid decimal places, we can always write at least 4 decimal places. But for this value, it was, I've written it to 5 decimal places. But if someone wrote 0.4063, he would still get the marks. However, we always prefer fractions simply because they are more accurate. There is no error in the answer, except this situation whereby rounding off might have taken place. So that is how we would do such a question for number 1.